Okay, I've had a few questions about this one here. And this is where it says the line y equals mx is a tangent, tangent meaning it touches at one point on, in this case, a parabola, which is y equals x squared plus 4. M is a constant, so it doesn't change, it's just one thing. Determine possible values of m. All right, so there's possibly more than one value of m. In other words, it possibly touches the parabola at more than one place. Well, let's have a look. Let's see if we can work that one out. So let's write down that information first. So we've got, and this, by the way, is theta mathematics, and it's was it 29.01, and it's question, in this case, 24. All right. So the question involves y equals mx. Notice this is in the gradient intercept form. It's like y equals mx plus c. But in this case, because we don't have a c value, it's like saying y equals mx plus 0, yeah? So in other words, if we're going to draw that, and which we can draw that, nice and straightforward, really. Here's our graph. And the graph is y equals mx plus 0. So it's going to go, the graph's going to be this, and the gradient is equal to m. M's the gradient. So the gradient could be there, could be there, could be there, or whatever. What we know is, though, it goes through the 0 point, it goes through the origin, there it is. This is being the y-axis, and this over here being the x-axis. So here's our line going through, and it could be anything. We don't know. Ugh, not that one. Okay, so any line but that one, folks. Let's kill that one. That's not a great way to go. So that was me being a little bit careless with my drawings. I mean, I meant to sketch it, but I didn't mean to mess it up as well. Oh, righty, so these ones go down here. There's another one going down here. There it is. Okay. All right. So after we've recovered from that disaster, let's have a look at the next bit. And that was y equals x squared plus 4. So in other words, we've got, here's our parabola again. Here's our straight line again. But this time we've got a parabola, y equals x squared. Well, y equals x squared is there, like that, yeah? There's x squared plus 4. So it's up here, well, that's 4. And it's going to go down here like this. It's going to turn around like that and head back up there. So that's roughly what it looks like. And in other words, the straight line crosses at a point like this. It goes along like this and just touches it like there, yeah? Or it could go from the other side, yeah? It could go like this. It could then just touch it there like that, yeah? So it crosses at one point and the parabola keeps on going. Crosses at one point and the parabola keeps on going, yeah? So that's what we're looking at. So we've got that straight line is there, and the parabola is that one there. And what we're finding then is those points there where it crosses. Well, let's have a look and see if we can do that. So we've got y is equal to this and y equals equal to that. And because they're both equal to y, it must mean that they're both equal to each other. So I'll start with this one here. So I've got x squared plus 4 is equal to mx. And I won't bother putting the 0 in, but I will subtract mx from both sides. There it is. So this now all equals 0. So I've got an x squared plus 4. In fact, let's put it in orders of x. I think because we've got an x squared there, let's do an x to the 1. So we've got mx to the 1, or just mx, plus 4. So we've got a little quadratic here now, but we've got a challenge because although we've got an a term here, a is obviously the coefficient of this, which is going to be a 1. We've got a c term over here, c is 4, but the b term is a non-integer coefficient of the x. In other words, it's an m. So b is m. So to resolve when we have a non-numeric coefficient of an x value, we use the discriminant. In other words, we've got the discriminant is equal to b squared minus 4ac. And in this case, it's going to touch at just one point. It's going to do it twice, but it's touching at one point. So I'm going to make that equal to 0. All right, let's see what this is. And by the way, you'll notice I actually made a mistake here. I just suddenly realized. And by the way, the mistake is immaterial, okay? And the reason it is, and I'll show you in a second, is I subtracted mx from this side, and I subtracted mx from this side, so this should be minus mx. And that would normally be a pretty bad mistake to make, but it makes no difference, because here it doesn't matter if I make m negative or positive, because I'm about to make it b squared, and I'm about to make m. So it wouldn't matter if it was negative m squared or just m squared, it's still going to be just m squared, yeah? So that's b squared minus 4 times a was 1, times c, which is 4, is equal to 0. So let's see how this plays out. So we're going to have, it's going to be m squared minus 4 fours are 16, times 1 is 0, 1 is 16. So I've got m squared minus 16 is 0. I'm going to add 16 to both sides. There it is. So m is equal to 16. M squared, sorry. So I'm going to find the square root of this side and the square root of this side. Of course, the square root of a square leaves me with an m. And because I've taken the square root of this and from square, I'm just going to go plus or minus here. So the plus or minus 16, square root is going to be plus or minus 4. There it is. All right. So we've got a plus or minus 4. So what does that tell us? It tells us that the value of the gradient, this gradient here is going to have a value of 4, yeah? So the gradient here is going to be a value of 4. This gradient here is going to be a value of negative 4. So the gradient here, I'm going to write this in, m is equal to negative 4. And here, I've got gradient is m, I've got a 4 there already, is equal to 4. And that's what that tells us. All right, so they're the possible values of m, in other words, the gradient of the straight line, are such that it intersects with the parabola at just one point, and that's how we would go ahead and find that. Hopefully that makes sense.